In this question, we have an element of material which is subjected to the following state of stress. Sigma x is minus 15 MPa, sigma y is 90 MPa, sigma z is 30 MPa, tau xy is 40 MPa, and we know that tau yz and tau zx are equal to 0. In part A, we will determine the principal normal stresses and principal shear stresses. In part B, our goal is to determine the maximum normal stress and the maximum shear stress. And finally, in part C, we will find the directions of the principal normal stress axis and show them on a sketch. To start, we can find the center of the circle. Let's call it A. It will be equal to sigma x plus sigma y over 2, which is 90 minus 15 over 2, and it will give 37.5. And let's show sigma x and sigma y in the circle. Let's say this is the point minus 15 to minus 40. And this is the point 90, 40. When we connect these points, we will get A. And this point is equal to 37.5. Now, let's calculate the radius. Radius will be equal to sigma x minus sigma y over 2 square plus tau xy square. So it will be 90 plus 15 over 2 plus 40 square. And r will be equal to 66. Sigma 1 will be equal to A plus R. This means it will be equal to 37.5 plus 66, and it is 103.5 MPa. And sigma 2 will be equal to A minus R. And we get sigma 2 is equal to minus 28.5 MPa. So we can say that this point here is sigma 1 and it is equal to 103.5, and this point here is sigma 2 and it is equal to minus 28.5. We know that sigma z is 30 and it will be equal to sigma 3. So that's all for the principal normal stresses. Now let's find the principal shear stresses. We have tau 1 here, tau 2 here, and tau 3 here. Tau 1 will be equal to sigma 2 minus sigma 3 over 2. And we know that it is 29.25 MPa. Tau 2 will be equal to sigma 1 minus sigma 3 over 2, and it is 36.75 MPa. And finally, we know that tau 3 will be equal to sigma 1 minus sigma 2 over 2, which is 66 MPa. We are done with part A, so we can move to part B. We know that sigma max will be equal to sigma 1, and it is 103.5 MPa. And tau max will be equal to tau 3, which is equal to 66 MPa. Now we can move to part C. At first, I will calculate theta n. So we have theta n is equal to 18.65 degrees. Let's assume that this was our axis before the stresses. This is x, this is y, and this is z. But now it will look like this, and this is y. And this angle will be 18.65 degrees. So our element will look like in the beginning, but finally and this angle will be 18.65 degrees. And also we will have sigma 3, which is 30.